start the stream. Apologies for the lighting of the camera today. I just was trying a new angle, and the window was just there in the very middle. Let me just start the live stream. Sorry, because I'm doing both. I'm doing both. So today we're doing we're doing farther the Solana the Solana bot the Solana bot learning plan. Yeah, we're doing that further today. Technology. Yes, everyone, start now. Yeah. All right, cool. Let me just get that up and running. Audio looks good. This looks good. I'm gonna post these. Last live testing. So I'm kind of going to be testing the changes that I implemented yesterday, by the way. So now if I do these, okay, perfect. So audio off. All right, I'm gonna get started, right? And as I said last time, one of the things that I'm doing is I'm not. I'm sorry for the light. This is awful. I'll change the angle at some point. I'll figure out a way to. But I'm just kind of trying to organize a bit the desk here. And what I will do is I'm gonna be more focused on actually doing the Think Aloud protocol than the stream, right? So just because I need to kind of focus on the interface and do the thinking out loud. If you have any questions, anything, just drop stuff in the comments. We started the Solana blockchain basics. And what I'll do is I'm gonna leave that for now. I think we covered a lot already. I mean we didn't cover much. We just covered the basics, the very basics. Yeah, no, maybe I should spend some more time. I want to see what else. So especially spend low fees and to understand its edge for high frequency trading bots. So let's resume the lesson first of all. Now I have Greco-futurism. I'm gonna pick, and let's see. So that's gonna resume the lesson. And again, as I said, I did deploy all the changes yesterday from the feedback that I gathered, and it's a lot actually of changes. So let's see how that feels today. If that feels a bit smoother. I made some key changes, especially around the interface, and you will notice that now there's no anymore like a third panel here, and it's all packed in here. Anyway, I'm gonna get started because I don't have too much time, so I'm gonna probably wrap it up in we'll probably do another session. I'll probably do a session again of like 15-20 minutes, something like this. Okay. And again, apologies for the this room is a mess. Maybe like this is better for now, but it's a mess, so I have to find a better way to. It is what it is. It is what it is. So the light is a bit disrupting right now here, but it is what it is. All right, let's get started. Cool. So what we talked about last time was what do we already understand about blockchain technology, and we haven't covered Solana before. So what we did last time was already the concept of the hashes, right? That the blocks are linked by hashes, and so they have the hash of the previous block. That's what we did last time. I'm gonna send this to a chat. And to be honest, when I was looking at the resources, I didn't really have a lot more. So what does Helios say here? Blocks chain together by storing the previous block's hash, which creates a tamper-resistant link. For Solana, what's one thing you're wondering about how it actually produces or agrees on those hashes at high speed? I mean, the high speed is actually an interesting aspect because I know that high speed is not something that. And by the way, let me stop for a second. I noticed that I tend to do that a lot. I think a lot out loud because I know I'm on stream, right? I need to do. I think I need to do one session where I just, instead of doing a live stream, I maybe record myself or just do one session without like an audience, just to get a better feel, because I'm not so sure if I'm really experiencing the tool the way that a regular user would experience it. But anyway, so the high speed aspect of it is gonna be an interesting one. I think the way that wondering guys actually. So I think the agreement happens. I don't know. Really don't know how this agreement actually happens. Maybe maybe you can tell me or help me kind of go down this path. I know that Bitcoin does this with cryptographical challenges or something like that. Bitcoin's proof of work puzzles make agreement slow and expensive. Exactly. So Solana needs a lighter way to reach consensus at high speed. And what's your first guess? What could it be? It could be. I mean, I've heard from the previous session there was something around proof of history, but I don't even know why. How would you do that? How would you actually? Yeah. Proof of history. Yeah, but that's because I mean, but I don't know how this I don't know how this works at all. If it's a way to prove that time has passed and events occurred in a certain order, what simple trick do you think a computer could use to generate that proof without miners racing puzzles? To be honest, I think this could be something along the lines of checking what? I mean, checking timestamps, but like a timestamp could be basically a timestamp could be basically manufactured. But if it's a thing where we have the hashes and then the timestamps, then essentially these proves that these timestamps were correct. But then why? How would you? How would you agree? I mean, it's hard because, and maybe let's me. So what do we have? So we have a block, and then we have another block, and these blocks have the timestamp or have a hash maybe, right? So you have the hash of the previous block, and then you have. By the way, I fixed that thing that this doesn't kind of disappear anymore, and then you have like what a timestamp. But why would that like if? Yeah, maybe. I mean, could it be that what's happening is like if I'm a node, if this is a node, and if this is a node and I'm suggesting these, and then maybe what's happening is really like a kind of a merge thing, right? Where essentially that goes, so you have these, and then the result is a merge, sort of a so if this is red and this is blue, and then this is blue and this is green. Sorry, this is blue and this is green. So maybe what's happening here is that at the end, what wins is, you know, whatever from a timestamp perspective is just using those things. But then like how is this being merged? Because that would mean that then it still could happen that things don't get merged correctly, right? So I'm just submitting these and see what Helios says. So what might be what might they represent inside a single node that could generate an ordered verifiable record without waiting for other nodes? A timestamp? Oh, that's something that a user told me that happened actually before. A timestamp. What property would let every other node trust the other without calling a central block on solving puzzles? The hashes? hashes? Huh. I'm gonna snapshot these. I think that's a grok error. I have to go check that with the console. So that's usage. But I cannot see any logs or anything, right? Usage. Limits, maybe. Costs. Observability. Okay, I can take a look at this later. Cancel into top error messages today. 22. Okay, I'll take a look at this later today. There must be something in here, but anyway, maybe maybe I can add something like a retry. You know what I mean? Yeah. Okay. This means this. Okay, cool. So I think what I was gonna say is so if what property would let another node trust the order without calling a central clock or solving puzzles? I don't know. I'm trying to think out loud here, and I would say a node generates that timestamp through its color blocks. The hashes, right? That's what I'm trying to say. The hashes. Okay, that is actually a problem. Let me see if there's anything else that is happening here. The hashes. Oh, now it worked. Now it worked. Okay. If each new hash must include the previous one in a fixed sequence, how could that chain itself act as a clock that other nodes can verify fast? But I'm not so sure. I don't think that's the problem here, right? The problem is that the problem is, yeah, this makes no sense, by the way. Also, I'm just this stuck message, because so we're working through some questions. So the problem here is that if each new hash must include the previous one in a fixed sequence, how could that chain itself act as a clock that other nodes can verify fast? Some sequence numbers? Like some sequence numbers? I don't know. Well, it happens quite often now. I don't know if it's basically, am I being throttled because I'm using the service a lot? It might be, because it just keeps complaining about the error. How could that chain give every node both order and the sense of elapsed time without them all talking constantly? Well, this would have to be, it would actually have to be a sequence. That's what I'm trying to say. feeling a bit stuck. Can you probe me around these a bit more? Give me some ideas, please. This also makes no sense, by the way. Sure, let's probably Canvas already has the node, the chain of hashes, and the timestamp questions. Imagine one node keeps hashing its own recent output in a tight loop. One node keeps hashing its own recent output in a tight loop. What could that repeated ordered hashing prove to every other node without them doing the same work? I think I need to give me some resources on proof of history. I think I need to go and actually do some reading on these. No, I just need to I just hit resources. See what it loads actually. Okay, so we've got blockchain, Solana, Wikipedia. No, those are too generic. I'm gonna go to the Grokpedia, and I'm gonna basically Solana. Proof of stake, proof of work, proof of authority. A hash chain. In a decentralized blockchain. Oh wait, actually, maybe I can just keep playing that, and then I can share my screen actually, and then just go here. So in a decentralized blockchain, nodes must agree on the order and timing of events. A verifiable tamper-proof record of time directly on the ledger using cryptography. Nodes can independently verify when events occur on their sequence without talking to each other first. Start the hash chain. Begin with initial seed value, hash. Repeatedly compute, hash, n+1. Oh, it has a... Really? It has an underscore number? On a single core. You cannot meaningfully parallelize or speed it up. The delay... Yeah, of course. So this must be done sequentially on a single core. You cannot meaningfully parallelize or speed it up. Each iteration takes real wall clock time. When a transaction event arrives, stamp it into the current position in the chain. Take the latest hash, add the new data, compute the next hash, record the current hash output, iteration count, how many steps done, and then insert it data. This creates an immutable link. The data is now cryptographically bound to that exact point in the timeline. So based on these, so does it mean, okay, so based on these, stop capturing the data. So based on I'm gonna put that in the notebook. So based on these, essentially the hash contains a counter. The hash contains a counter, and you cannot parallelize these, right? Because if you parallelize these, you would actually get, you wouldn't know really when you're processing blocks. Your history would not agree. So is that the hash contains also a counter? You see, the problem is I still don't see how that is something that brings that makes it verifiable. And by the way, sharing screen just makes it no sense. I think sharing screen makes it a bit odd. Hop for a bit of tool work. So you compute the hash. Hash n, yeah. In the chain. Take the latest hash, the new data, compute the next hash from the combined input, and record current hash output, iteration count, how many steps done. The proof, so the published proof, the current hash value, the count of iterations performed, the data in the event that was inserted, because the function is pre-image resistant, extremely hard to reverse, and sequential. Anyone can verify to reach this hash at this count, all prior steps must have been computed correctly. Proportional to the count. Computing the chain takes time, the delay. Verifying a proof or checkpoint is quick. Nodes don't need to rerun the entire history. They can check specific segments or use optimized verification. Time travel attacks. You cannot reorder events without breaking the chain. Yes. The sequence provides both an upper bound and a lower bound. Each validator runs a POH service in the background, constantly advancing the hash chain. Slots and leaders time is divided into short slots. The POH sequence determines which validator is the leader for each slot. Block, okay, but there is then sequence. Cranks through the VDF to reach its assigned slot, stamps incoming transactions into the current POH state, and proposes a block. Okay, but there is some centralized voting, right? This is what I'm not sure where the advantage is really, because you do have validators. So okay, so you do have fine. You produce a hash. The hash has a counter. embedded into it. You cannot kind of time travel to these. You must actually do the iterations in software terms. Otherwise, it won't be agreed. And so fine, you cannot reorder things. That's all good. But it's something that you would actually, the reordering doesn't mean the time. You know what I mean? The reordering would actually work without the timing. That's what I'm not so sure about. That makes sense. The future attacks, this makes sense. So you essentially have that clock, and you make sure that you cannot kind of post something that is like a future transaction. But essentially, this is just validation. You want to validate that things are correct and whatnot, right? Fine. But proof of work, like the proof of work or whatever, or proof of stake, is more like a competition, right? And here's like you have nodes don't need to rerun the entire history from Genesis. They can check. Yeah, that's fine. The proof of checkpoint is quick. You still have a mechanism advancing the hash chain. Deliver VDF. The Tower BFT proof of stake layer. Each validator uses the published BFT as a trusted timeline. They're still voting, so there's still proof of stake. Let me see. There is still proof of stake voting as a layer on top of that, right? Boy, this error. That is actually a problem. It happens more than I thought. So it's proof of stake voting on top of proof of history. Proof of history already gives validators a fast share record of event order. What do you think the voting layer can? But then, okay. But let me do these. If you have a proof of stake voting mechanism, then the proof of history is not really what brings the speed, is it? Oh, come on. Even with POH giving a fast share record of event order. Like which one? So which one is the next valid block? Is it because the voting process doesn't need to check that the whole proposed history is correct on each of the cases? I don't know, to be honest. I'm gonna, yeah, I don't know. I think I'm gonna, I don't know. I have to stop here. It could be interesting to kind of save a bit of a snapshot of a session to come back to at some point, but I'm not so sure. That's kind of a feature idea. Anyway, cool. No, I think that looks good. It looks good. Maybe the interface gets very busy quickly. I'm not so sure if I can have these. Can I make? Anyway, that's as a feature idea, and this is a problem, man. This is quite a problem. Anyway, that was a good session, I think. See you guys later tomorrow, I guess.